Alright, so in this problem, I have 49 to the power of x minus 42 to the power of x is equal to 36 to the power of x. So I'm going to first start by dividing every term by 49 to the power of x. So then these two cancel out, and now I get 1 minus 42 to the power of x over 49 to the power of x is equal to 36 to the power of x over 49 to the power of x. Now 42 over 49, that's the same thing as 6 over 7. And 36 over 49, that's the same thing as 6 over 7 squared to the power of x. And now I can actually switch the places of 2 and x. So this is the same thing as 6 over 7 to the power of x squared. And now I'm going to let 6 over 7 to the power of x equal to the variable y. So now I have 1 minus y is equal to y squared. And this is the same thing as y squared plus y minus 1 is equal to 0. Now, you have to use a quadratic formula to actually solve this, but if you do, you end up getting that y is equal to negative 1 plus or minus the square root of 5 over 2. And now remember how we let 6 over 7 to the power of x equal y. So now I have 6 over 7 to the power of x equal negative 1 plus the square root of 5 over 2. So let's first start with this. I'm going to take the log on both sides. So now I have log of 6 over 7 to the power of x is equal to log of negative 1 plus the square root of 5 over 2. So now I can move this x to the front and divide both sides by log 6 over 7. So now I have these two cancel out. X is equal to log of negative 1 plus the square root of 5 over 2 over log of 6 over 7. Now, we can also do the same thing with negative 1 minus the square root of 5, but it would just be the same outcome, but instead of plus, this is going to be minus. So I also have x is equal to log of negative 1 minus the square root of 5 over 2 over log 6 over 7. Alright, so in this problem, I have 99 to the power of x plus 9 is equal to 9,999 to the power of x plus 9. So to solve this, I'm going to first start by using the property of exponents that says a to the power of m plus n is equal to a to the power of m times a to the power of n. So by using this property, 99 to the power of x plus 9, that's going to equal 99 to the power of x times 99 to the power of 9. And 9,999 to the power of x plus 9, that's going to equal 9,999 to the power of x times 9,999 to the power of 9. Now I'm going to divide both sides by 99 to the power of 9 times 9,999 to the power of x. So then these two cancel out for my left-hand side, and these two cancel out for my right-hand side. So now I have 99 to the power of x over 9,999 to the power of x is equal to 9,999 to the power of 9 over 99 to the power of 9. Now this is the same thing as 99 over 9,999 to the power of x, which is equal to 9,999 over 99 to the power of 9. And now this simplifies to 1 over 101 to the power of x is equal to 101 to the power of 9. And this is the same thing as 101 to the power of negative x is equal to 101 to the power of 9, meaning that negative x is equal to 9 and x is equal to negative 9. So now to check, I have 99 to the power of x plus 9 is equal to 9,999 to the power of x plus 9. We know that x is negative 9, so now I have 99 to the power of 0 is equal to 9,999 to the power of 0. Anything to the power of 0 is 1, so I have 1 is equal to 1. And this is right, so I know my solution is right. Alright, so in this problem, I have 8 to the power of x plus 2 to the power of x is equal to 130. So to solve this, I'm going to first start by rewriting 8 as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 130. And I can actually switch the places of 3 and x. So this is the same thing as 2 to the power of x to the power of 3 plus 2 to the power of x is equal to 130. Now I'm going to let 2 to the power of x equal to the variable y. So now I have y to the power of 3 plus y is equal to 130. Now I'm going to subtract 130 on both sides. These two cancel out. So now I have y to the power of 3 plus y minus 130 is equal to 0. Now I'm going to rewrite y here as negative 25y plus 26y. Now I have this minus 130 is equal to 0. And now y to the power of 3 minus 25y, the greatest common factor is y. So I get y times y squared minus 25 plus 26, y minus 130, the greatest common factor is 26, so I get 26 times y minus 5 is equal to 0. And y squared minus 25, that's the same thing as y plus 5 times y minus 5. And now if I factor out y minus 5, I get y minus 5 times y plus 5 plus 26 is equal to 0. So now this gives me two equations. I have y minus 5 is equal to 0, which means y equals 5, and I have y squared plus 5y plus 26 is equal to 0. And to solve this, we actually have to use the quadratic formula, and I'm not going to waste your guys' time by doing it, but if you do end up doing it, it actually won't work because you get the square root of a negative number, and you can't take the square root of a negative number. So we are left with y equals 5, and remember how we let 2 to the power of x equal to y. So this means that 2 to the power of x is equal to 5. And I'm going to take the log on both sides to solve this, so I have log 2 to the power of x is equal to log 5. And if I have something in the form log a to the power of b, I can move this exponent to the front, so it's going to equal b times log a. So this is the same thing as x times log 2 is equal to log 5, meaning x is equal to log 5 over log 2.